Welcome to the second part of our three-part video series on LLM, RAG, and MCP. Three powerful techniques that are modernizing the way we build robust AI system. In this series, we'll explore how these technologies work individually and together to create intelligent, scalable, and context-aware solution. Hello everyone, welcome to my channel C3 and AI, where we explore the world of cloud, container code, and AI. I'm Gautam, and I bring over 20 years of experience in designing, managing, and supporting Microsoft Enterprise Services. Today, we are kicking off second part of our three-part series focused on building robust AI system using RAG. Let's recap on first part quickly, which was based on LLM, where we have discussed the key component of large language models, their architectures, and again their training process. Then we have discussed use cases of LLMs, and then the last we have discussed how LLM is evaluated from GPT-1 to GPT-5. Though we have seen the entire journey. If you want to go through in details, I will put the comment link in the comment section. So please go through on that. So now as we know that LLM, RAG, and MCP together enable AI to understand context, retrieval real-time data, and act intelligently, and that is transforming business workflows with smarter, adaptive automations and all. So today I will present the details of RAG, and where I will try to touch some of the important part of RAG, like vector database and all. So let's start with RAG, and let's see what we are going to discuss. So first we discuss what is RAG, and then we'll discuss how RAG works, where a step-by-step explanation of RAG workflow from user query to AI generate answers. Then we'll discuss about the detailed overview of RAG architecture and system flow. Then we'll go on some more details on vector database and how it is powering to RAG. And then we'll discuss the key capabilities of vector database. And in the last, we'll discuss about the evolution of RAG patterns and RAG use cases. So let's start with what is RAG. So RAG stands for Retrieval-Augmented Generation. It is a technique used in AI and natural language processing that combines retrieval-based methods with generative models that is produce more accurate and contextually relevant responses. So what RAG does? This is a primary question with everyone wants to discuss. So retrieves relevant information from external sources like documents, databases, or websites based on the user's query, and augments the overall generation process by feeding the retrieve data into a generative model like GPT and all to produce a more informed and context-aware responses. So if you want to understand RAG in very simple terms, so for example, you ask a question. It can be like, what is zero trust security? So how it does it? The system looks for answer in documents. It searches a databases or articles, PDF, or internal files to find the most relevant one. Then it picks the best matching content that can be the document that can be closely related to your the questions. Then it gives the content to the AI model. The AI rates this selected documents to understand the topic better, and then the AI writes an answer using the content. So the response is accurate and based on real information, not just guesses. Why it is powerful in general? Because again, this is the main question from everyone asking why RAG is so powerful nowadays. So actually, it allows the model to access up-to-date or domain-specific knowledge without needing to retrain the model. It helps in reducing hallucination, that is kind of made up or inaccurate answers, and it enables customization for enterprise use cases such as querying internal documentation or knowledge base. So if you want to go in details how RAG works step by step, so we have to go in because primarily 5 steps it is involved in that. So first step is external data preparation. So here the data from sources like API, document, websites, it try to see, and then these databases are chunked into a manageable pieces. Each chunk is converted into a vector embedding using an embedding model that can be sentence, BERT and all. And then these embeddings are stored in a vector database. In coming section, we'll discuss more details in what is vector database and all. And the end goal of this step, the first step is to enable fast semantic search based on meaning, not keywords. The second step is query encoding. Here the user's query is transformed into vector using the same embedding model. These vectors represents the semantic meaning of the query. And the third step would be the document retrieval. Here the query vector is compared against store vector in the vector database using similarity matrices, like it can be Gaussian similarities. And here the system retrieves top k most relevant documents based on semantic closeness. The fourth and important step is prompt augmentation. The retrieved documents are appended to the original query. This forms an endless prompt that provides context to the language model. Think of is as a giving the model background reading or before answering type of things. And the last is response generation. Here the endless prompt is passed to the language model like GPT-4 or Llama, and then model generates a response that is context ever grounded in retrieve facts and more accurate and relevant. So if you want to go in details how the system flow of RAG architectures and all, so again it is based on the same process like retrieval, then second step would be augmentation, and then your once data and all combine, the queries combining and all, then it's moving to the generations and third step in the generation, and where your model like LLM and Llama come in the picture, and then it is giving the kind of best response or its enhanced response and all. We want to go in details of vector database primarily, so let's touch on that. So what is vector database primarily? A vector database is a specialized type of database that is designed to store and search vector embedding, which is nothing but a numerical representation of data that captures semantic meanings and all. These embeddings are typically generated by machine learning models and are used in applications like semantic search, recommendation system, and retrieved augmented generation in the like RAG. So why that vector database matters in RAG. So in a RAG system, the retrieval steps depend on finding documents that are semantically similar to a user's query. This is done by embedding the query into a vector. The searching the vector database for similar document embedding, and then retrieving the top k relevant documents to pass the generative model. So everyone say that powering vector database is helping or giving the power to RAG. So it is true, because there's all process like it can the documentation ingestion and embedding, then query embedding, then similarity search, then context retrieval and all, and the last augmented generation. These all steps are coming from primarily from vector database itself. The key capabilities of vector database in RAG, we know that semantic search, where it finds relevant content based on meaning, not just keywords. Then scalability, where it efficiently handles millions to billions of high dimensional vectors. Then metadata filtering, this is the kind of the metadata filtering enables filtering by attributes like tag, source, dates, or document type as well. And the real-time updates, it supports the dynamic addition, deletion, and updating of documents and embedding. And then hybrid search, like combines vector-based semantic search with traditional keywords of search for precision and all. Primarily, we have seen that the benefit of vector RAG is coming in most of the enterprise use cases, where primarily I would say their use cases in the enterprise knowledge assistance, where people are creating some of the internal system that supports for their employee, like answering HR policies or IT-based policies and all. Then customer support automation, pulling relevant help articles or troubleshooting guides to resolve customer issues. Legal document analysis, because not necessary to read such a large documents and all. Here this is helping searching cases, law, contracts, and compliance documents. And healthcare decision support, where use cases is again like assisting doctors with treatment protocols and medical research and all. Nowadays, this is very important, that how RAG patterns moving from simple to highly sophisticated and all. So initially, it was a naive RAG, which is again the kind of basic starting point of RAG, where it is involving embedding a query, retrieving relevant text chunks, and feeding them directly into a prompt. while it was very effective for simple Q&A. It struggles with complex tasks like multi-hop reasoning, long context, and prone to hallucinations and all. The advanced RAG that represents a significant engineering leap, incorporating techniques such as pre-retrieval filtering, hybrid indexing, re-ranking query, rewriting and all, memory, and then post-retrieval predictions. It employs modular pipelines like example retrieve, read, and predict to enhance accuracy, context handling, and traceability, and that is making it suitable for more demanding applications and long-running applications. Then it comes to a graph RAG. The graph RAG contributes, again, it is helping combining structures and semantic retrieval by integrating knowledge graphs with vector database. This approach retrieves both relational and unstructured data, enriching the prompt with graph path and node metadata that is more helping to explanation of any reasonings. It is particularly useful in a fields where requiring structured logic such as enterprise search, healthcare, and finances. The agentic RAG is again nowadays is presented as the most powerful pattern where the model transcends all those features. It intelligently decides what to retrieve, which tools or function to call, and how to store the results. By dynamically involving APIs or external actions based on prompts, retrieve data and all, it is helping a lot. And that is, it is really important for comprehensive stack, including like tool functions, graph database and all. So these, you have seen that from naive RAG to agentic RAG travel a very more intelligent journey now. So in the last, I would say the RAG powers intelligent assistants, customer support boards, legal research tools, healthcare advisors, and more. That is helping AI systems smarter, safer, and more useful in practical scenarios. Maybe we can discuss more on in coming time. Thanks for your time. And in next series, I will discuss the last part of this series about MCP. If you like this, please subscribe the channel C3NI and let me know for any questions and answers. Thank you. Cheers. Okay. Bye.